National Electrical Code Article 230.70b addresses service entrance conductor splices. Service conductors that enter a building or other structure must be installed in a raceway, auxiliary gutter, or other approved enclosure. All splices and taps must be made within a raceway, gutter, or other approved enclosure. This means you cannot have splices in a pull box on service entrance conductors unless that pull box meets the requirements of an approved enclosure. The purpose of this requirement is to ensure that service entrance conductors are properly protected and that any splices or taps are made in a safe and accessible location. An approved enclosure provides physical protection for the conductors and splices, preventing damage from external factors such as moisture, dust, or physical impact. It also helps to contain any potential electrical faults, reducing the risk of fire or electric shock. Furthermore, the enclosure provides a readily accessible location for inspection and maintenance, allowing electricians to easily check the condition of the conductors and splices and perform any necessary repairs or replacements. Article 230.70c covers raceway extensions. Where service conductors enter a building or other structure through a raceway, the raceway must extend inside the building or other structure to a point at least 18 inches from the wall, partition, or other support. This requirement is intended to provide additional protection for the service conductors as they enter the building. By extending the raceway at least 18 inches into the building, it helps to prevent damage to the conductors from physical impact or other hazards. It also provides a clear and defined point of termination for the service conductors, making it easier to connect them to the building's electrical system. The NEC defines a service entrance as the point where electrical power enters a building. This typically involves high-voltage conductors and requires careful attention to safety and code compliance. Service entrance conductors are the wires that run from the utility company's connection point to the building's main disconnect. These conductors carry the entire electrical load for the building, making it crucial to ensure their integrity and proper installation. A raceway is a general term for any enclosed channel designed to hold and protect electrical wires. Common types of raceways include conduits, electrical metallic tubing, and cable trays. Auxiliary gutters are metal troughs or enclosures used to supplement wiring spaces at meter centers, distribution centers, switchgear, and similar points. They provide additional space for conductors and splices, making it easier to manage and maintain complex electrical systems. An approved enclosure is a container that meets specific safety standards and is designed to protect electrical components from environmental factors and physical damage. These enclosures are typically made of metal or durable plastic and are tested to ensure they can withstand various hazards such as moisture, dust, and impact. Splices and taps are connections made to join two or more electrical conductors together. Splices are typically used to extend the length of a conductor, while taps are used to connect a new conductor to an existing one. Both splices and taps must be made using approved methods and materials to ensure a secure and reliable connection. Article 314 of the NEC covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and hand-hole enclosures. These enclosures are used to protect electrical connections and provide a safe and accessible location for wiring. The specific requirements for these enclosures depend on the size, location, and intended use. Article 314.16 covers the volume of outlet, device, and junction boxes. This section specifies the minimum volume required for boxes based on the number and size of conductors, devices, and fittings installed in the box. The purpose of this requirement is to ensure that there is enough space in the box to properly terminate the conductors and devices without overcrowding or damaging them. Article 314.17 covers conductor entries into boxes, conduit bodies, or fittings. This section specifies the requirements for how conductors enter these enclosures, including the use of bushings, connectors, and other fittings to protect the conductors from abrasion and damage. The purpose of this requirement is to ensure that the conductors are properly protected as they enter the enclosure, preventing damage that could lead to electrical faults. Article 314.27 covers the mounting of boxes, conduit bodies, and fittings. This section specifies the requirements for how these enclosures are mounted to walls, ceilings, or other surfaces, ensuring that they are securely fastened and properly supported. The purpose of this requirement is to prevent the enclosures from becoming loose or detach, which could create a safety hazard. Firstly, use the correct type of enclosure for the environment. Secondly, ensure the enclosure is properly grounded. Thirdly, do not exceed the full capacity of the enclosure. Fourthly, protect conductors from abrasion. Fifthly, make secure connections. For example, if the service entrance conductors are exposed to weather, an M3R enclosure is required to protect against rain and ice. All metal enclosures must be properly grounded to provide a path for fault current and prevent electric shock. The full capacity of an enclosure is the maximum number of conductors that can be safely installed in the enclosure without overcrowding. Overcrowding can lead to overheating and damage to the conductors. Use bushings or connectors to protect conductors from abrasion as they enter the enclosure. Abrasion can damage the insulation of the conductors, leading to electrical faults. Ensure all connections are made using approved methods and materials and are properly tightened. Loose connections can cause overheating and electrical faults. The NEC is updated every 3 years, so it is important to stay current with the latest edition. State and local jurisdictions may have additional requirements that are not covered by the NEC. Always consult with a qualified electrician before performing any electrical work. If the project was turned down due to a pull box with splices on the service entrance conductors, it indicates a violation of NEC Article 230.70b, which requires splices to be made within an approved enclosure. It is crucial to rectify this issue by relocating the splices to an approved enclosure or reconfiguring the service entrance to eliminate the need for splices outside of such enclosures. Always consult the latest edition of the NEC and local electrical codes to ensure compliance and safety. Working with electricity can be dangerous, and improper installations can lead to fire, electric shock, or other hazards. Always take the necessary precautions and follow all applicable codes and regulations. Service entrance conductors, as previously mentioned, are the wires that bring electrical power from the utility company's connection point to the building's main disconnect. Because they carry the entire electrical load for the building, it's essential to handle them with care and ensure their integrity. A splice is a point where two or more conductors are joined together to create a continuous electrical path. Splices must be made correctly to ensure a reliable and safe connection. An enclosure is a protective box or housing that surrounds electrical components such as splices, connections, and devices. Enclosures provide physical protection, prevent accidental contact with live parts, and protect against environmental factors such as moisture and dust. A raceway is a channel or pathway designed to hold and protect electrical wires and cables. Common types of raceways include conduits, tubing, and cable trays. Raceways provide physical protection, support, and a neat and organized way to run electrical wiring. Auxiliary gutters are metal troughs or enclosures used to supplement wiring spaces at meter centers, distribution centers, switchgear, and similar points. They provide additional space for conductors and splices, making it easier to manage and maintain complex electrical systems. Taps are connections made to an existing conductor to draw power for another circuit or device. Taps must be made using approved methods and materials to ensure a secure and reliable connection. Approved means acceptable to the authority having jurisdiction. This typically refers to a qualified electrical inspector or other regulatory agency that is responsible for enforcing electrical codes and standards. The authority having jurisdiction may have specific requirements or interpretations of the NEC that must be followed. An example of a service entrance conductor splice in an unapproved pull box is a situation where the main power lines from the utility company enter a building and are connected to the building's electrical system. If these connections are made inside a simple metal or plastic box that does not meet the requirements of an approved enclosure, it would be a violation of the NEC. Instead, the splices must be made inside a listed and labeled enclosure that is specifically designed for this purpose. It is also important to ensure that the enclosure is properly sized to accommodate the conductors and splices without overcrowding. Overcrowding can lead to overheating and damage to the conductors, which can create a safety hazard. A qualified electrician will be able to determine the appropriate size and type of enclosure for the specific application. Always consult with a qualified electrician before performing any electrical work, especially when dealing with service entrance conductors. These conductors carry high voltage and current, and improper handling can be extremely dangerous. In summary, NEC Article 230.70b requires that all splices and taps on service entrance conductors be made within a raceway, gutter, or other approved enclosure. Article 230.70c requires that when service conductors enter a building or structure through a raceway, the raceway shall extend inside the building or structure to a point at least 18 inches from the wall, partition, or other support. This is to ensure the safety and integrity of the electrical system.